Let's talk about diodes. Theories, principle, types, classification, circuits, illustration, and application.
A diode is a device that acts like a conductor since it allows current to pass in one direction, known as forward biasing, and it acts as an insulator since it blocks current passing in the opposite direction, known as reverse biasing. The diode is comprised of a p-type material combined with an n-type material such as this. Current flows from the negative terminal of the battery to the n-type and through the p-type and then returns to the positive terminal of the battery. When the diode is at rest, it will look like this. The p-type consists of holes or positive charged particles, and the n-type consists of free electrons or negative charged particles. Diode as a conductor, when a voltage is applied, current will flow. This causes the holes to move toward the depletion region and the free electrons to move toward the depletion region. The depletion region shrinks, allowing current to flow. This is forward bias. We will look at the diode as an insulator. When the battery polarity is reversed, the holes move away from the depletion region, as does the free electrons, expanding the depletion region, thus restricting the movement of current. This is reverse biasing.
A diode is a semiconductor gadget that effectively switches current in a single direction. By significantly limiting current flow in the opposite direction, it permits easy flow in one direction. Due to its ability to convert alternating current AC into pulsating direction current, diodes are sometimes referred to as a rectifier DC. Type voltage and current capability are used to read diode. Anode positive bled and cathode. The component of a diode define its polarity, negative bled. The majority of diode only let current to flow when the anode is subjected to positive voltage in this diagram. Many diodes combinations are shown.
Types of diodes. Light-emitting diode. In forwarding bias, then the current flows through the junction and generates the light. Laser diode. Used in many applications like DVDs, CD, drives, and laser light pointers. GaN diode. Used for producing microwave signals. Zener diode. Used to provide a stable reference voltage. Schottky diode. Used in rectifier application, clamping diodes, and also in RF application. Photodiode. Used to detect light, photodiodes operates under reverse bias condition. Pay-in junction. Used in RF or other low current application.
So in this slide, we're going to talk about half-wave bridge rectifier. So on the previous slides, we discussed reverse and forward biasing of diode. So here, halfway bridge rectifier is a one of many application of diode. So here there's a load or voltage input and a diode. As you can see, there's a full wave cycle, then a zero, then full wave cycle, then a zero. Why? Because there's a forward and reverse biasing of a diode. If it reverse, there's a zero. If it's forward biased, it will make a sine wave. Next one, full wave bridge rectifier. So there's a for diode. When it's forward biased, there's a two diode operating and two diode not operating, and this will lead us a continuous sine wave with no zero, flat zero. And next one is LED circuit, voltage input DC, then a diode, then a resistor. So typically diode will operate at 2 volts.
So now, let's talk about the applications of diode. Here, I listed all of the possible applications that can be used in our daily life. It is number one, it is used for rectification, as a switch, the source isolation, also as voltage reference, the frequency mixer, also it is used in AM envelope detector or demodulator, or it is also known as the diode detector, as a light source, also as a temperature sensor, as a light sensor, a solar a cell or photovoltaic cell.